Record. Okay. All right. So Jolie, Jason, that's kind of weird. The first four people in the room all had the same first letter to their name. What's the chance of that? Jeff, Jolie, Jason. Okay, now we got an M in here. McKenna. Okay. All right. Let me see. It's going okay, McKenna?
Yes.
Okay. So how many classes are you taking?
I have this class, and then I have marine biology, psychology, and I have a health and wellness class.
Okay.
And my marine biology has a lab, so.
Okay. So your teachers there are being creative on how to get around this.
Absolutely.
Yeah. Marine biology sounds kind of cool. There might be some interesting stuff to learn in that class.
It is. I'm kind of sad because I was really looking forward to dissecting a shark at the end of the semester, but now we'll just have to do it over video, I guess.
Well, somewhere I clicked the wrong button, so let me minimize that and see. Okay, we're back to where I want. Yeah. Well, the only marine biology, the closest I've come to marine biology is going out on fishing boats.
Mm-hmm.
I took a psychology. Yeah, I took a psychology class in college, and it was kind of interesting because the guy that actually taught the class was, you got to remember, this is back in the mid 1980s, early 1980s, when they were just starting to figure out that like chimpanzees were a lot smarter than people thought they were. He was one of those that would, spend 8 hours a day living with the chimpanzee. You know, he'd pull breakfast duty, so he and the chimpanzee would have breakfast together. And the chimpanzee would put its dishes in the sink and do all that type stuff. And I remember one day he was talking. He says, "Yeah, chimpanzees. Sometimes I get excited, and they forget that they're about 8 times stronger than us humans, and that we have thin skin compared to them." And so all of a sudden, the teacher in the front of the room takes his shirt off and turns around. So we're looking on his back, and he's got these big old scars in his back.
Oh,
and
no.
it's where the chimpanzee got a little bit excited and bit him.
Oh my gosh.
Yeah. I do remember that class just because of that one story you told us. Yeah. Well, okay.
Is this how we're going to have all of our labs?
Yeah. Yeah. Mm-hmm.
Okay.
Yeah, we're not going to be back on campus. If you look in the folders, this week is the molar mass. Next week is the thermochemistry.
Right.
I've already got all of it uploaded. And then the lab after that, the atomic spectra, is coming out of chapter 7. I've got that one all loaded up. So you can actually do the labs independently. You can do them ahead of time if you want, or you can just wait till we go over them like we are here this morning. That's totally up to your choice. I think what I might do is, for the students that want to work ahead, is I might do a voiceover of the labs, the same way I've done with the lecture, just to provide a little bit more detail if you want to get ahead. I'll probably get caught up on some of that. I won't do a voiceover on the molar mass since we're doing that right now. But by this time next week, in a couple of days, I should get voiceovers done on the next week's lab, the thermo lab. So we'll go that way. So you can see in this document, okay, this is the actual lab procedure that you would have ordinarily done yourself in lab. So what's been done, and some of you may have already looked at all this, is we've got this video link right here. And this is actually, I think it's Dr. Giletti kind of introducing it. And then Dr. Windham is the one doing the experiment. And I think it's Mr. Alan Patton doing the video. So as you watch this experiment online, you'll have your lab report right here beside you, and they'll actually be going through the procedure just the same way you would have gone through the procedure. But I do get a kick out of that in that it says, do not handle dry ice with bare hands. And that's precisely what you see Dr. Windham doing. He just picks it up and puts it in the beaker with his hands. And in fact, I should admit that's the same thing. That's the same thing I do when I show students. If your hand's not wet and you're really quick, that's the best way to do it to get better results. So as you watch the video, you'll record data into your data table here. So you'll be able to record the air temperature. They'll show you the thermometer. They'll, at the end of the carbon dioxide subliming, they'll take the temperature of the CO2 in the flask. They'll show you the thermometer. They'll show you the barometric pressure. So you'll just record all that, as well as the mass of the stoppered flask, air intake, and all that. So they'll do the experiment. You can pause you can pause the video to give you time to write down the data in your table. I do point out here that during the video, when they're measuring the volume of water that was in the flask, it's kind of hard to get a really good reading of the volume. So I'll take that into account. And as always, you're not being graded on accuracy. You're being graded on have you done the calculations correct? And are you answering the other questions correct? It tells you what density to use earlier in the lab. And it also just points out we're only doing one experiment. And so you can neglect this average here that is required, that is asking you for. And I did point in here on the pre-lab assignment that if you've done the pre-lab assignment correctly, you should get that the identity of your gas is what's called dichloromethane, CH2Cl2. So it should come up with, I think the molar mass of dichloromethane is something like, what's that, is about 84 or 85 grams per mole. So if you've done this one correctly, you should get 84 or 85 grams per mole. And then the calculation for your carbon dioxide gas is done exactly the same way. And typically, when students do this in the lab, they typically come pretty close to what it should be, 44 grams per mole. And having watched Dr. Windham do the experiment, I suspect, I haven't done the calculation myself yet, but I suspect that if you do your calculations correct, you should come up with something pretty close to the 44 grams per mole that we know it should be. Suppose, why is it important to determine the mass of air in the flask? Well, because if we look back here, we need to know the mass of the carbon dioxide. And so we need to know the mass of the empty flask. So if we take the mass of the empty flask, well, if we take the mass of the flask plus carbon dioxide and subtract from it the mass of the empty flask, we can get the carbon dioxide. Well, the empty flask doesn't have any air in it, so we need to subtract out the mass of the air. And if we know the volume of the air, which is also the volume of our carbon dioxide, that is equal to the volume of the water. And if we know volume and we know density, we can get the mass of the air. So that's the first question there. I am recording this, and what I'm going to attempt to do is to put the recording to where you can have access to it in YouTube. Right now I'm running into some difficulties, but I'm trying to work my way around those difficulties to get it up into the YouTube cloud to where you can view it. Okay. Question number 2 here. what happens, of course, since carbon dioxide is extremely cold, any water vapor in the laboratory will start condensing out. And so actually when you go and you add the dry ice into your flask, you're not only adding carbon dioxide, but you're also adding water. And so you'll have, when you calculate your mass of CO2, it's not only going to be the mass of CO2, it's going to be the mass of water. Okay? So when you take the mass and divide it by the moles, you're going to have extra mass, and so you're going to have an extra high molar mass. So that's why in the procedure, it says to be very careful that your dry ice doesn't have any time to, be sure to use dry ice. If any moisture appears, you need to start over again. Okay. And then on this next question, if you don't use enough dry ice, here we need to remember something in chapter 5, is that the average molar mass of air is about 28.8 grams per mole. We know that the molar mass of carbon dioxide is 44, and we learned that at the same temperature and pressure, as molar mass goes down, density goes down. So if we in fact have our flask with a little bit of air, the flask is going to have a little bit lower density, and therefore the flask is going to weigh less. And if the flask weighs less, we're going to end up with a smaller molar mass. So that's why when you do this experiment, we have you, or Dr. Windrum made sure to use more than enough dry ice so that when it sublimed, it was more than the volume of the beaker, the flask that he put it in. So as the dry ice sublimed, there was more than enough carbon dioxide gas to push any of the previous air outside, so that to ensure that the only gas left in our flask was in fact carbon dioxide. Okay, this question here is kind of an oddball. It's kind of a difficult one to know what they're asking for. So from your data, you calculated the density of CO2 because you knew the mass and you knew the volume. Okay. So what it's asking you to do is just to take the ratio of what your density is based upon your data and divide that by the density of air that you were given earlier in the lab, and just come up with a number. And then take the true molar mass of carbon dioxide, 44 grams per mole, divide that by the molar mass of 28.8 for air, and come up with a number for that. And then you want to do a comparison between your result here and this result here. The closer your result here is to this result, the better the experiment went. You know, if the experiment was perfect, this density divided by this density should be equal to this density divided by this density, because they were at the same temperature and pressure. So this is just a way of seeing just the accuracy of your experiment. Okay. All right, so this one's just looks like a ideal gas law problem. So PV equals nRT, but we need to remember that pressure must always be in atmospheres, and we need to remember that temperature must always be in Kelvin. So just do the necessary conversions before you calculate the gas at the new conditions. So that's coming right out of a chapter 5 problem that you had experience with before. Okay. Does anyone see any questions that you have relating to the lab that I may not have just mentioned?
With question 5 on the post lab. Instead of the ideal gas law, wouldn't it be PV over T? Wouldn't it be the combined gas law?
You could use it, yeah, it would be the combined gas law, you're correct. But once again, yeah, if you, temperature has to be in Kelvin, so swap those temperatures to Kelvin. And we have to make sure we either convert torr to atmospheres or convert atmospheres to torr, your choice on that. But yeah, you're correct, McKenna. I think that was cool, McKenna, yeah.
Awesome.
So great. So once again, on these labs, if you want to work ahead, you're certainly welcome to. So this lab would be due no later than this time next week. So if you want, because this is an MS Word file, you can actually type your results and type your calculations as best you can into the MS Word document, save it, and then just send it to me as an MS Word. That would keep you from having to scan it or to take a picture with your phone and sending it to me that way. That's why we tried to provide these laboratories as MS Word files now. That might make it easier on you. Okay. Any other questions beside McKenna's? No? Okay. So go ahead, and like I've done on the previous labs, on the previous labs, you had the spreadsheets to put your data in that did the calculation and let you see whether you did the calculation correct or not. We can't do that right now, but again, you should come up with something pretty close to 44 because typically this experiment works pretty good. If you submit it and I see you have some errors, I will make comments and resubmit it back to you for corrections, just like what we would have done in lab, but just with a little bit more effort. So with that being the case, don't wait until the last minute to try to submit it to me so that I have time to get it back to you if need be. Okay. So if there's no further questions about lab, do any of you have any questions about, well, McKenna, you're all in lecture. If you've been working on lecture, I guess we're going to get back together here at, I think it's 12:30, yeah. But if you have any questions right now that for lecture, I'd certainly respond to any lecture questions right now as well. Okay. Well, no, okay.
When is the next homework due?
I'll send out an announcement on that. But again, what you want to do, if you're at all not, this is what I told my 152 students this morning. If you're at all not comfortable, you're doing them all correct, just send them to me a couple at a time. Well, that's what I sent out to my chemistry 130 lab students as well. They've got about 15 molecular, total ionic, net ionic equations to do. So I told them, I said, do about 3 or 4 of them, submit them to me so that if you are making any mistakes, you won't make the same mistakes over all 15 of them. So if you see a lot of problems from the lecture course that seem to be somewhat related, just do a couple of them, send them on to me, and let me comment on those. If you're at all unsure that you're doing them correct. If you're sure you're doing them all correct, just do them all at once, send them on to me. But certainly you can send them a few at a time if you wish. We'll deal with it that way just as well.
Okay.
So the first homework, again, I'll send an announcement out. It should be done probably next Tuesday back to me. But again, don't wait till the last minute, because if you do have any mistakes, I'll get it back to you. You can rework it a bit, then get it back to me before the deadline. So I'll also announce today our next exam will be probably no later than, no earlier. It may be on next Thursday. I may give you access to it on next Thursday. because that'll be just a fair amount of good material for the next exam. Oh, for lab exam, I did want to point out, we do have a lab exam at the end of the semester. And typically what it is there's questions, you know, maybe we've done 11 experiments. And so on the lab exam, there's 11 different problems. Each problem relates to one of the experiments, where I have you do things that you've already done in the course of turning in that laboratory experiment. What I've done with my 152 students is, instead of waiting till the end of the semester to give them one lab exam with 11 different experiments on it, I'm giving them one with 7 and one with, no, they're doing 12 experiments. I've given them one lab exam with 7, and I'm giving them a second one with 5. And I would be completely cool with doing the same for you. Like the labs that you've already turned in would be lab exam 1, and these remaining ones would be lab exam 2. Send me an email how you, well, let me just see here. If you don't have a microphone, type in what you want. And McKenna, would you prefer one long one near the end or 2 shorter ones? McKenna, are you there? Are you thinking about it?
Probably 2 shorter.
Okay,
just
2
so
shorter
that I
ones.
can get the feel of how it'll go for the first one, and then if needed, I can know for the
Okay.
second one.
What do you think, Jill? Do you one long one or 2 short ones? 2 shorter ones?
Yeah, I think 2 short ones as well.
Okay. All right. Jason, Joey, do you are you okay with that? 2 shorter ones? If you're
I'm
not,
fine
just
with
type in a no in the chat down there. And okay. Okay. So what I'll do probably be next week as well. So the homework would be due for lecture like on Tuesday. Next week on our lab meeting next week, I will have a lab final over the labs that you've already turned in. And I'll get that out to you next week then. Okay. Any other questions any of you have? So I suspect in between now and our meeting at 12:30, you'd ought to be able to knock this lab out and have it done. Okay. So, all right, I'm going to then, if there's no further questions, I'm going to close the meeting and then see if I can't get it up on YouTube for everyone. All right. I suspect I'll see the 4 of you here at 12:30. So y'all take care till then. Okay. All right. Bye.